If your security team is drowning in alerts from too many scanners and dashboards, this review will help you evaluate whether ArmorCode is the right consolidation layer. ArmorCode is an application security posture management platform founded in 2020 and based in Palo Alto, California, that uses AI-driven normalization and prioritization to bring findings from more than 320 security tools into a single system of record. The company reports processing over 40 billion findings across Fortune 1000 companies, which underscores its ability to handle high volumes at enterprise scale. Let's start by defining the problem ASPM is meant to solve. Modern application security relies on a mosaic of scanners and platforms. You might run SAST for static analysis of code, DAST for dynamic testing of running apps, SCA to detect vulnerable dependencies, container security to evaluate images and registries, and cloud security posture management to catch misconfigurations in cloud accounts. Each tool is valuable but creates its own alert stream, data model, and UI. Without a unifying layer, teams bounce among 10 to 30 dashboards, duplicate tickets pile up, and remediation SLAs get missed. ASPM sits on top of those tools to centralize findings, align them to applications and services, and orchestrate workflows that actually close issues. How does ArmorCode specifically address this? First, it ingests findings from a broad array of scanners and platforms. The ingestion pipeline normalizes fields from different vendors so that severities, CWE identifiers, CVEs, affected assets, and timestamps can be compared consistently. This alone reduces friction, because you can filter and report across tools with a common taxonomy. Second, ArmorCode applies AI and analytics to deduplicate and cluster-related findings. For example, if the same vulnerable library appears across multiple microservices or environments, deduplication helps prevent opening 5 tickets for what is effectively the same dependency upgrade. Clustering by application, service, repository, environment, or business unit also helps create owner-aware queues so that the right teams receive the right issues. Third, prioritization is enhanced by adding context. Pure CVSS scoring is not enough in complex environments. Teams want to know whether an asset is internet-facing, whether an exploit exists in the wild, whether an affected service handles regulated data, and how the issue maps to policy requirements and SLAs. In an ASPM, these context signals feed into risk scoring and policies so that high-impact issues surface to the top across tools. ArmorCode's approach aims to direct developer attention to the smallest set of changes that will deliver the biggest risk reduction. Workflow is where value becomes visible to engineering. Findings that clear deduplication and prioritization are routed into existing tools engineers already use, commonly issue trackers like Jira or ServiceNow. Tickets can be automatically created with the normalized metadata, ownership, and due dates derived from policy. As fixes are committed and rescans occur, the ASPM reconciles state, closing tickets when remediation is verified and resetting SLAs when regressions reappear. This closed-loop workflow reduces the manual back and forth that causes alert fatigue and delays. Reporting and governance are core expectations in regulated enterprises. Program leaders want unified dashboards that answer questions like, how many open criticals do we have across code to cloud? Which teams are meeting or missing SLAs? What is the mean time to remediate by severity or by business unit? Which tools are producing the most actionable findings versus noise? By centralizing all findings, ArmorCode can surface these metrics without asking analysts to export CSVs from every scanner and wrestle them into spreadsheets. Consistent evidence trails make audits faster and help leadership connect security investment to measurable outcomes. A frequent question is how ASPM differs from vulnerability management platforms, SIEM, or CNAPP. Vulnerability management traditionally centers on host and network exposures and is often scanner-specific. SIEM focuses on runtime logs and detections rather than pre-production code issues. CNAPP gives deep cloud-native visibility but may not unify code repo and pipeline findings. ASPM acts as the connective tissue for application risk across development and runtime contexts, aggregating the outputs of specialized tools rather than replacing them. What about deployment and integrations? The practical path begins with connecting your highest signal scanners in your primary ticketing system, then rolling out additional connectors in phases. Early wins come from eliminating duplicate tickets, consolidating dashboards, and standardizing SLAs. Because every organization's stack is unique, you should validate that your SAST, DAST, container scanners, Cloud accounts and CI pipelines have ready-made connectors. The breadth of supported integrations is a major selection criterion. ArmorCode advertises more than 320 integrations, which is meaningful if you have a diverse toolchain. Does ArmorCode truly reduce noise? Teams report that consolidation and deduplication alone meaningfully reduce volume. Add context-based prioritization and routing by ownership, and you can shrink the backlog to a manageable set. The degree of reduction depends on data quality and policy tuning. As with any security analytics platform, initial setup to calibrate fields, tag critical assets, and define SLAs is critical to outcome quality. Let's address pricing and ROI considerations. Enterprise ASPM is typically sold via custom quotes, with cost drivers like number of connectors, data volume, environment size, and users. Because hard costs vary, value is best assessed by modeling time saved per analyst and per developer, reductions in mean time to remediate, and audit preparation time saved. Consolidation can also defer purchases of point dashboards and reduce the need for custom reporting projects. Who benefits the most? Organizations with microservices architectures, multiple business units, and strict compliance requirements typically see outsized gains. If you are already using many scanners and your developers complain about noisy or duplicative tickets, an ASPM can be a relief valve. Smaller teams with a single scanner may not need ASPM until their tooling and services grow. How does ArmorCode compare to alternatives? The ASPM and exposure management market is active, with vendors focusing on different strengths such as developer experience, policy automation, or cloud-native depth. Your evaluation should emphasize connector coverage, deduplication accuracy, scoring transparency, ticketing integrations, role-based access controls, reporting flexibility, and the ability to map findings to business contexts like application tiers and data sensitivity. Scale matters as well, and ArmorCode's claim of processing tens of billions of findings signals attention to performance and data pipeline reliability. Implementation best practices include starting with an application and business unit inventory, mapping owners, aligning SLAs to risk tiers, and piloting with a few teams that can provide structured feedback. Define what success looks like in the first 90 days, such as percentage reduction in duplicate tickets, time saved consolidating reports, and improvements in SLA adherence. Then expand connectors and policies in waves. In summary, ArmorCode positions itself as a high-scale, AI-enabled ASPM that centralizes findings from hundreds of security tools, applies context-driven prioritization, and orchestrates developer-friendly remediation workflows. If your security program is struggling with tool sprawl, inconsistent triage, and slow remediation, an ASPM layer like ArmorCode can provide the unifying framework you need. The decisive factors will be integration coverage for your stack, the clarity and trustworthiness of prioritization, and measurable gains in developer productivity and risk outcomes over your first few quarters of adoption.